का थोड़ा डिस्कशन हम करना नहीं चाहते। वैसे स्टेट सिंबल्स का मतलब होता है कि यू आर टॉकिंग अबाउट a solid substance, are you talking about a liquid substance, or are you talking about a gaseous substance? Obviously बात है, since we haven't done solid, liquids, and gas, there is a chapter. So, right now it is quite obvious that we are unable to identify. But for your understanding, this is a solid. That's basically liquid. That's a solid, liquid, and carbon dioxide is a gas. But this is not what we are discussing right now. What we are discussing right now, or what we should be doing right now, is the question that says a student found that 2.5 grams of zinc carbonate required 20 cubic centimeter of dilute nitric acid to react completely. Okay, that's one of the things. So if the question talks about zinc carbonate, so since you don't know the formulas right now, so we can just start off with zinc carbonate is this, nitric acid is this. So they say mass of zinc carbonate is 2.5 and nitric acid's volume is 20 cubic centimeter. Now the question is calculate the concentration of dilute nitric acid using the following steps. So calculate the concentration. Now think, what is concentration? So concentration was, we did this, represented by C, and that was number of moles per unit volume. Remember, we did this. Have you done this formula? In the last class, I think we did this formula, right? Yeah, okay. Then we can skip this question. We'll come to this question later on. Don't worry about it. Just give me a minute. I'll bring up a relevant question. Volume wala question we have to do. Uh, yeah, we can start up with this. So, for your reference, this question is from this year. You may want to note this up. That is May, June 2017, paper 4.2, question 5B. That is for your reference. Now, this is the question which you want to do here. That's what we can do. Now, the question says the relative formula mass of silver chloride is 143.5. Now, what is formula mass? Formula mass is basically the molecular mass for an ionic compound. So if you have something ionic in nature, that's chemical bonding chapter one, that is yet to be covered. So we are going to go through that later on. That's the ionic compound's molecular mass. So there is nothing new about it. We already know how to calculate molecular mass. So they've just given this up. So we can treat it as MR. And then it is calculate the number of moles in 2.87 grams of AgCl. Now tell me, can you identify any formulas which we can use here to find out number of moles? Yeah, there is one. That was number of moles equals mass over MR, right? So mass given is 2.87. Molecular mass given is 143.5. So once you divide it, you're going to get your answer. So is this understood?
Yes, sir.
That's nice. Good to hear finally. This is 0.02 moles. Uh, Now they say, uh, no, ionic equation we have not done, so we can skip this part. We can move towards the another question. Let me save this. Let's move ahead. Mhm. I think this we can do, yeah. So this question is the next question we are discussing. That is for your reference. You may want to note this down. So this question says, calculate the volume of HCl. That's the volume of this much HCl. They are asking about volume that is needed to react with 3.48 grams of MnO2. Okay, so that's mass. So first thing is moles of MnO2 used. That's what they want us to find out. So let's find out moles of MnO2 used. So do we have any formula for calculating moles from mass? We just used that. That was number of moles equal mass over mR. So we'll come to this part of calculating volume later on. First, we have to find out the moles. So mass is 3.48 grams. Then we have to figure out the MR of MnO2. See, in this question, back in pre-COVID days, they don't used to give us molecular masses in the question. We have to go through the periodic table stuff. I'll show you the kind of periodic table you're going to have in your exams. This is basically the periodic table they're going to give you in your exams. So this is the sample of the periodic table. Okay. This is the same periodic table what you given to you guys. Yeah, I'm just about to explain that part. So see, this is the periodic table, right? Now we are looking for the mass of MnO2. So first we have to identify which elements make up MnO2. So there is this simple trick, Mn is manganese. That's one of the elements. Whenever you are stuck up with, identifying the state symbols, identifying the elements formula. So always remember the capital letter and small letter, they are read together. That means if you have something like NaCl, so Na is, first element, C being capital, Nl being capital are read together. Similarly, if you have something like, NO2, so it's like nitrogen and oxygen. Okay. So since this is MnO2, so Mn is manganese. Let's see where it is. So here it is, Mn. So now there are two numbers. Top number, that is always atomic number. See, they've given you this. And we are not, discussing atomic numbers right now. We have to find out AR, that's 55. So for Mn, it is 55. Do you guys get this part?
Yes, sir.
That's nice. Then we have oxygen. So let's look out for oxygen. That's oxygen. So top number is 8. That's atomic number, irrelevant right now. Bottom number is 16. So that's 32 here. Now why 32? Why have I taken 32, not 16? The thing is, I am dealing with manganese dioxide. That is two oxygen, not one oxygen. So each oxygen is 16. Two oxygen makes up 9's 2. So that's 32. So I have to add both of these. 55 plus 32, it is going to be 87. Do you guys get this?
Yes, sir.
That's nice. Let's come to the original question. Now, so that was the mass. We just calculated MR, that is 87. So we can use this formula, that is mass over MR. It's very, good to use formulas, to write formulas, because, in case exams, in your final answer, in your final CIs, you might get your final answer wrong, but still examiners, they are, generous enough to give you marks even for writing formulas. So the answer is 0.04 moles once you divide. Do you guys get this part?
Yes, sir.
That's nice. Now, this is basically moles of MnO2. We have just figured this out. That is 0.04 moles, right? Is that correct? Now, if you see this
Yes.
equation here, in this equation, you see for every 1 mole of MnO2, that is very important. I want you guys, to pay close attention to this. For every 1 mole of MnO2, what we have is 4 moles of HCl, right? Remember, we talked about this. Whenever you see any numbers in the equation, they represent moles. So if you, kind of forget about it, so that's kind of a review. They're always moles. If there is no number, that means it's 1 mole. If it is 2 written, that means it's 2 mole. Still no number, that means 1 mole. So that means 4 moles of HCl. That means according to the equation, whatever the number of moles is for MnO2, it's actually taking 4 moles of HCl, right? Do you get this part? So what I can deduce from this is MnO2 and HCl, they have their mole ratios as 1 is to 4. Do you guys get this part?
Yes, sir.
Okay. So how many moles of Mn we have? We have just calculated MnO2. That was 0.04 moles, right? So that means the moles of HCl required would be X, that's unknown. So you can, use this ratio proportion technique. That would be X times 1. equals 4 times 0.04. That's x is equals to 4 times of 0.04. That is 0.16 moles. So if you are good at maths, you can just figure this out, since there is one mole of MnO2 reacting with 4 moles of HCl. So you just can directly multiply this. You don't have to go through it. But I was just explaining, in case. Did you get this part? So I did 0.04 moles here, and then I made this X. It was pretty much obvious since 1 mole is producing 4 moles. So, for 0.04, it should be 4 times of the original answer. Yeah, ratio part is coming from the equation. See, Bushra, if you see the equation from MnO2 and HCl, they are basically reacting in this ratio, 1 mole and 4 moles. But we have calculated this much moles of MnO2, right, in part 1 here. So we need to find out the moles of HCl. That's what the question was, right? So we use this ratio proportion. So we, kind of cross multiplied and we figured X out, and that comes out to be 0.16. Okay. Take your time and let me know if there is anything, that needs more clarity. Is this understood, Peter? Pushta, do you get it? Still confused? You have anything, any question, any doubts? Pushta, can you hear me? Yeah, no problem at all. So see, we calculated moles here. That was 0.04 moles, right? Now I went to the equation. Equation me, what I see is there is 1 mole of MnO2 reacting with 4 moles of HCl. So now the question asks us about moles of HCl needed, right? So instead of using any of the formulas, we are using ratio proportion. And what's that? I see 1:4 ratio of MnO2 and HCl. Do you get this? So 0.04 moles would now produce X moles. That's what I assumed. Then I cross multiplied and I, get to have this answer. Do you get this? Bushra, do you get it? Are you sure? That's nice. Okay. Now what I have is 0.16 moles here and 0.04 moles here. Okay. Now they say volume of HCl needed. That was what the original question was. Calculate the volume of this much, kind of concentration. So we have 8.00 moles per liter. That's basically concentration, right? Concentration is something new to you guys, so don't worry about it. Now they want me to find out, volume. I already had calculated moles, right? That is 0.16 moles. So if according to the same technique which I used in part B, that was ratio proportion, I can move on with this equation that says 8 moles are present in 1 liter, right? Is is this expression, kind of rewritten this way? Is that possible? 8 moles? per liter, right? Per cubic decimeter. Is that correct? Do you guys get this part?
Yes, sir.
That's nice. How many moles I have? That is 0.16 moles. So let's make this X, right? Then still we can work this X out, right? So that means 8X would be equals to 0.16. X would be equals to 0.16 over 8. What do we have here? 0.16 divided by 8. So that is 0.02 moles. Sorry, 0.02 liters. I was working for volume, right? Do you get this? Now, the question asks me volume in cubic centimeters. Do we have a formula that relates cubic decimeter with cubic centimeter? I think we did that, right? And that was 1 cubic decimeter contains 1,000 cubic centimeter. So if I'm having 0.02 cubic decimeters, I'll have to just multiply it with 1,000. So I'm going to get cubic centimeters. So let's multiply it with 1,000. So that's 20 cubic centimeter. Do you guys get this? Are you sure?
Yes, sir.
That's nice. That's great. Good job. Now, this is one of the questions which I read. Now I want you guys to try one question. Mhm, mhm, mhm. Yeah, let's try this. This part. So it says lead nitrate. That is lead nitrate. And the elements it has is lead, nitrogen, and oxygen. And I'll give you the masses. Let's try to read it from here. Where is PB? That's PB. That is 207. Coming back here. So lead is 207. Nitrogen is 14. Oxygen is 16. So I think this would be a bit difficult for you guys. Let's just skip this question. Don't worry. We'll do this later on. I want you to try a similar question, exactly similar question, so that you feel confident. Yeah, you can do this. 3.40 gram sample of sodium nitrate, that sodium nitrate, which is Na23, nitrogen 14, oxygen 16. You have to find out number of moles, then you have to find out number of. Yeah, you can try this. I'll wait for a few minutes, but there is, one request. You don't have to call out the answer. You can, if you have the answer, you can just write it in the chat box. If you don't have the answer, then let me know. I'll wait for a few minutes. Okay. Yes, Bushra. Done?
Yes, sir.
Okay, let's see if you guys have done this correctly. First of all, we have to find out the MR of NaNO3, and that is going to be 23 plus 14 plus 48, and that would be 85. Now, since we had mass, so we can use this formula. So that would be 3.40 over 85. So the answer to first part would be 0.04 moles. Is that correct?
Yes, sir.
Good. Then they say moles of oxygen. So for that, no problem. For that, we can use this ratio proportion. That is 2 is to 1. So you can see for every 2 moles of NaNO3, we have 1 mole of oxygen. So 2 is to 1 is the ratio between NaNO3 and O2. So we have around 0.04 moles here. Let's assume this to be X. So cross multiply it. So this would be 2x is equals to 0.04, x is equals to now 0.02. 0.02. Right? Do you get this part?
Sir, how is x equal to 0.02?
See, basically, once you divide 0.04 with 2, so you'll get this answer.
Okay, sir. Thank you.
Now, yeah, uh, see, Bushra, we have calculated the moles of this, right? And then they have asked us the moles of oxygen, right? So we just used the same ratio proportion technique. Since this was 2 written here and this was nothing written here, that means that is 1. So the ratio between NaNO3 and O2 was 2 is to 1. Okay. So we had 0.04 moles of NaNO3 in part 1. So we assumed X moles of oxygen, right? Since oxygen's mass is not given, so there is no other way to calculate, moles of oxygen. We can only use ratio proportion. And then I have multiplied them, cross multiplied them, and then get this answer. You get this? Okay. Now they say find out the volume. So we have moles of oxygen. What should I do to find out volume? So the formula was number of moles is equals to volume upon 24. I'm having 0.02, volume is unknown, that's 24. You shift it here, so that becomes 24 times 0.02. So this would be 0.48 liters. So now tell me, do you guys get this part? Yeah, no worries, Bushra. We won't be skipping anything, so don't worry about it. We'll be doing that much questions so that you feel confident. These are like, one-to-one sessions, so don't worry about it. I don't keep many students in a class so that, I have to rush on with this syllabus completion and things like those. I would explain each and everything till everyone, gets the complete idea of it. So, do you understand this now? That is important. Good job. Nice. Uh, So I'll share the entire file with you guys so that you can, attempt these questions whenever you're free. So you'll have access to this PDF file and, you can enjoy solving these questions. If you are stuck, in any of the parts, so I'll explain that in the class. Don't worry about it. Okay. So let's end it here, right? And see you guys in the next class. Okay.
Assalamu alaikum, teacher.
Walaikum assalam wa rahmatullahi wa barakatuh, teacher. Okay. Allah Hafiz. Take care. Allah Hafiz.
Love this.